first topic is that your homework number 1 is due tonight. So I'm also going to try using these live transcripts, and yeah, and that's the next thing I wanted to mention. Thank you for that question. Every time you get a correct question, it's recorded. So you don't have to submit anything. Once you get a little check mark or you get your points, that's in your grade book. And again, I'm not super picky about deadlines. I just want everyone to keep up with the assignments. But if you need a little more time, just let me know either on XYZ through the messaging or send an email. So if you haven't been able to sign up for something, you can meet me in office hour. I'll help you create your account, and then you can have a homework extension and get started on homework problems. Okay, and then in a few weeks, I'll transfer all your homework scores from XYZ over to Canvas, and that way you know your class grade. Next is quiz number 2 will be posted today. I'll have it up by tonight on Canvas. Quiz number 1 was the assessment that you did last week, which thank you everybody. It went really well. I really appreciate the work you did on the quiz. If you would still like to take that quiz, I can grade it for you. Quiz. Okay, so quiz 2 will be due on the 14th. Okay, so I would like to do just a few examples for adding fractions or subtracting fractions. And also just a side note, in any math class, even like high-level math classes, it can be tedious to work with fractions. So we're just going to practice and then move on to notes for homework 2. And I'm pretty sure homework 2 is available either today or it will be available tomorrow. And homework 2 is due in a week. So that's also due on the 14th. So I did check in the book and on Google that 0 over 0 is undefined. Any number divided by 0. So 2 over 0 is undefined. Keep going, like for any numbers x and y, let's have 30x squared y divided by 0. It would be undefined. Okay, so this is the weird one. And you can take notes. I think it's good to write the notes down, but if you want to just watch right now, that's fine too. This is recorded, so you can always come back later and do notes. But just as a, like, and thanks for the question, by the way. Just as a side note, I think it helps to write as a hobby, like to journal, to have notes, especially if you're in school, or just whenever I want to learn something, especially about myself, I'll just have a notebook, lots and lots of scratch paper. Okay, so let's go on to adding and subtracting fractions. So I made a lot of examples, but I also have a lot of notes for your second homework. So if you want to go over more examples with me in office hour, I'm going to save like a couple of these. We'll start with this one. 3, 10. And then we'll do 2 more problems adding or subtracting fractions and then move on from the review. So again, I like to use a lot of scratch paper. I was going a little fast last week and not writing down all of my scratch work, but I'm going to try to show you all of the thoughts, as we work through the problem. So on this side, I like to find the LCD. Factor each denominator. I have 2 times 2 times 2. 10 is 2 times 5. So for the factor 2, you find the most, which is over here. There are 3 2's on this side, only 1 2 over here. Factor 5, it shows up at least 1 time. So 4 times 10 is 40. Using this factored form, I'm going to find missing LCD factors and multiply that numerator and denominator by the missing factors. So we have 2 and 2 and 2, so you need the 5 that's missing. Ten has the factors 2 and 5, so you need to multiply by those missing factors of 2. So times 4 over 4. We're at 15 over 40. Add 12 over 40. So we have the common denominator, and we can put 15 plus 12 over 40. And then I checked the factors of 27 and the factors of 40. Nothing canceled, so this is fully simplified. But maybe we should do that over a scratch record. So I just want to see if this is fully reduced. So 27 is 3 times 9. 9 is 3 times 3. 40. I factored it right here. So there were no common factors. So we're going to take 2/3 in the next example. It's 2/3 minus 7/5 plus 1/6. Okay, so we're going to need a common denominator for all of the 3 terms. Let's factor each denominator. 3 is factored, 5 is factored. 6 would be 2 times 3. 50 LC. One of the factors is 3. There's only one 3 from any denominator. We have a factor of 5 and factor of 2. So the LCD would be 30. You go to the first term, multiply the numerator and denominator by missing LCD factors. I have 3. I'm missing 5 and 2. Which would be minus 7 over 5. I've got 5, but I'm missing 3 times 2. For 1/6, you've got 2 and 3, but you need to multiply by 5 over 5. So this is just going to copy over here, running out of room on the whiteboard. Cool. 20 over 30 minus 7 times 6, 6, 7, 3, 8, 9, 40, 31, 2, 42. And now that we have the common denominator, we can have 20 minus 42 plus 5 over 30. Actually, this here. Okay, I did this a little differently than in my notes. So we're gonna have the difference between, let's do scratch work. 22 and 20. It's 22, but this would be a negative 22 and then plus 5. Okay, negative 22 plus 5 would be at negative 17. And it's over 30. So one more example like this, and then we're on to notes for homework 2. So we will take 1/10, add 2/3, subtract 1/6. So factor every denominator. 10 will be 2 times 5. 3 is factored. 6 is 3 times 2. One of the factors is 2. There's 1, 2. There's 1, 2. The other factor is 3. There's just 1, 3 over here. 1, 3 is the most I have. And there's 5. Just 1, 5. Okay. Then we'll take each term, multiply the numerator and denominator by missing LCD factors. Got 2 and 5, so you're missing, oops, you got 2 and 5, so you're missing 3. Second term, you have 3, but need 2 times 5. 6 factored into 3 times 2, so we're missing 5. So the first term is 3 over 30. Second term will be written as 20 over 30. Subtract 5 out of 30. So over your common denominator is 3 plus 20 minus 5. 18 times 20 will simplify. So we're going to continue the problem at the top of the board. Over to the side. They're both even, so I know that 2 times 9 can be 18. 2 times 10 is 20. 2 over 2 is going to be 1 9/10. Let's check if it's factored. So if it's fully simplified by using factoring. So we have 3 times 3 over 2 times 5. No factors in common between your numerator and denominator. So this is simplified. This is just scratch work to check that you have the right reduced fraction. The right reduced fraction. Okay, so we want to go on to homework 2. So it starts with the definition. We're going to define a solution to an equation. Or I guess just a we're going to stick with equations. A solution for an equation is a value, is a number that when used in place of the variable, it makes the equation true. So we're going to try problem like x, let's say, is x equal to 3 a solution to the following equation? where you have 2 plus x equal to 5. So we'll take that value of 3 for the variable x, put it into the equation, check if it's true. If the statement is true, then it is a solution. If the statement is false, it's not a solution. Let's just put it in there. So let's go with check. Yeah, 2 plus 3 equal to 5. So 5 equal to 5. Yep, that's true. So is an arrow to say then. So then x equals 3 is a solution to the equation. We're going to do another like this, where we're checking x equal to 0. Is x equals 0 a solution to x minus 1 equal to 4? So we're going to see if we put in x equals to 0, gives us the true statement, and it is a solution. But if it's a false statement, not a solution. So x equals 0, then you have 2 times 0 minus 1 equal to 4. So you're looking at 0 minus 1 equal to 4. Is negative 1 equal to 4? That means that x equal to 0 is not a solution. Okay, cool. This is cool. Is x equal to 3/2 a solution to we're looking at 4 plus x equal to 3x plus 1. putting this fraction in for x. 4 plus 3 halves equal to 3 times 3 halves plus 1. So we really don't want to move any of the terms around. You just want to simplify, or like combine these fractions on one side, leave this side how it is and just work with that, the numbers. Leave this side how it is and work with those numbers. But we don't want to start moving stuff around, like don't subtract 1 from both sides, or start with one side. 4 plus 3 halves. 4 over 1 times 2 over 2 plus 3 over 2. Okay, so just leave this kind of how it is, but we need to have a common denominator to actually add those together. And on the other side of the equal sign is 9 halves plus 1, which I'm going to rewrite 1 as 2 over 2. Okay, so we're going to go back over here and just work with this addition. So 8 halves plus 3 halves, so 11 halves. On the right side of the equal sign is 9 plus 2 over 2. So we've got 11 over 2. 11 over 2 equals 11 over 2. So when you have a true statement, that number is a solution. One more like this, and then we go on to solving linear equations. So is x equal to 1/2 a solution to didn't complete the thought in my notes, but I can figure it out. So let's do that. 1/2 a solution to put in a 2 times x plus 4 equal to 6. So putting in 1/2 for x, and we'll have 2 times 1/2 plus 4 equal to 6. So there's different steps to take next. You could either distribute 2 to both terms. We can add inside the parentheses and then multiply by 2. Let's do that. So 2 times 1/2 plus 4, 1 times 2. And I'm not trying to solve anything, so leave this 6 sitting here. Don't move it around. leave all this over here, just simplify it. So we've got 8 plus 1 over 2. Nine over 2. And is that equal to 6? And I'm at 9 equal to 6 because this 2 over 1 and that 9 over 2, they'll be multiplied together. That's going to reduce to 1 and leave 9 over 1, which is 9. That's false. So that would not be a solution. Now we want to talk about steps to solving equations. Let's label them with like step 1 is to use the distributive property if you need to. So in a sense, you're going to expand the problem. Combine like terms. So all the numbers values together, all the, like if there's x values, put those together. If any variable, put all of those terms with that variable together. You want to get the variable that you're solving for to one side of the equation using addition or subtraction. Let's see, use addition. So we're trying to get that variable isolated, and first we're going to get it over to one side of the equal sign. Or one side of the equation. And when we get there, we'll talk about how if you have one value equal to another, if you add a number to one side, you have to add the same number to the other side, so that way they stay equal. Or if you have two equal values and you divide one side by a number, you have to divide the other side by the same number so that they stay equal. So if you add to both sides of the equation. Or if you subtract from both sides of your equation. That way they can stay equal to each other. So what did I say? Get the variable to one side of the equation. Okay, last step. We're almost done actually. Number 4 and then number 5. Number 4. Use division or multiplication to isolate the variable. Last step would be to check your answer, which I'll have to remember to do. Sometimes I'm in a hurry and I skip it, but we need to stop and check. So just in case you're taking notes, this will sit here for a minute and I want to just talk through the steps. So especially if there's parentheses, you're going to be expanding the problem. And then after you have all of your terms, combine like terms on both sides of your equation. Start to get the variable you're interested to one side of the equation by adding values to both sides of the equal sign or subtracting from both sides of the equal sign. Then once you've got your variable on one side, isolate it by using multiplication to both sides of the equation or division on both sides of your equation. And you should have your variable all by itself, or you've solved for the variable. And then we should check our answer. First one will be to solve for x. Let's do this. All right, there's -4 times x minus 1 equal to 3 minus 2x. Got parentheses, so I do want to distribute. So I'm doing that first step. Take -4, distribute it to both of these terms here and here. So -4 times x, -4 times -1. Let's do arrows. Then -4x plus 4 is equal to 3 minus 2x. We're going to add, let's add 2x to both sides. So add 2x on this side of the equal sign. If it's going to happen here, I need it to happen over here, so that way they stay equal. So add 2x on that side, equal sign. A -4x with a positive 2x is going to be -2x. And this plus 4 equal to 3 And the goal kind of is to get the x values to one side. So I have x on this side over here. I'm going to get these numbers on the other side over to the right by subtracting 4. And again, you do it to each side of the equal sign so that the sides stay equal. So 3 minus 4 is -1. And now to get rid of that -2, we'll divide both sides by -2. Negative and negative is positive. 2 over 2 is 1 times x, which is x. And then this negative with that negative is a positive 1/2. And then we're going to check. Yeah, I think I did a little something back there that was a mistake. Thank you for catching it. And I'm gonna go and just redo my work. So backing up, I had a -4. There's x minus 1. Thanks for noticing that. It's equal to -3. It was -4. And I added 2x. So this is -2x plus 4 equal to 3. And then it was a minus. Why don't we subtract 4x? Or actually, I think I'm going to also, sorry, I'm checking my work, but I'm also going to solve it a different way, where it's going to have -4x plus 4 equals to 3 minus 2x. And let's work with the 4x. So we could add 4x to both sides. So this side is now 4. And this side has 3. 4x minus 2. -2x plus 4x is going to be 2x. I still got 1/2. I must have done something wrong in my notes. Anyway, -3 from each side. So I have 1 equal to 2x. And divide both sides by 2. So I did get a 1/2 equal to x. Oh, I think, I made a mistake in my notes. I wanted to just go on to a new problem. Apologize. But actually, let's check this in what I had written down in the first place. And then we're going to move on. Okay, so I think this. Okay. And then we went and solved it, and now we're checking it. So if you put in a 1/2, we would have -4 times 1/2 minus 1. 3 minus 2 times 1. So when you're doing this check, there's nothing to solve for. So don't move, don't add or subtract any values, just leave these numbers on this side and simplify that expression. Leave all of these numbers on that side and simplify that side. And then look at what you have and see if the numbers are equal. Okay, 1/2 minus 1. Right as for the other side, let's take care of 3 minus 2/1 times 1/2. So that 2/2 cancels or reduces to 1. This is -1/2 inside the parentheses. On the other side of the equal sign, we have 2. This negative with that negative is a positive 4/2. It helps, you could put 4/1. So 4 times 1/1 times 2 is 2. It's 1/2. X equal to 1/2 is a solution. And it turns out to be the only solution. So you could put is. Solution. Okay, that got a little messy. And the next one has fractions in it, so let's be extra careful. We have 5x equal to 1/2 times 12x minus 14. All right, so if you see parentheses, you will use that first step of distributing, and we're going to distribute 1/2 to both terms. So take that fraction and multiply it with 12x and over multiply with -14. And 1/2 times 12x is going to give 6x. 1/2 times -14 is -7. Let's get the variable x to one side of the equation, and I can do that by subtracting 6x from each side. And just like the last problem, there are multiple ways to solve the equation. As long as you follow the right rules, we'll get the same answer. This is one way to subtract 6x from both sides. a negative x on that side equal to -7 here. You need to isolate x, or you need to solve for x. But there's a negative sign. So you can multiply both sides by the negative, or you can divide both sides by -1. Either way. Let's multiply. Okay, so it's a positive x equal to +7. And I don't know, it's my style to like circle this, but before I do, I'm gonna go check it on the side. Okay. If x equals 7, we would have 5 times 7 equal to, so you have to go check in the very beginning of the problem, back to the equation that you're given, which was 5 times x equals 1/2 times 12x, which is 7 minus 14. Okay, I might need some help if you guys wouldn't mind shouting out some answers in the comments or something. I know like 7 times 5 would be 35. Let's leave the 1/2 sitting there for now. Actually, no. let's distribute the 1/2. That would help a little bit. Okay, and I've said this a few times, but when you do a check, you're not solving anything. So leave like whatever numbers are here, just leave them there and simplify that side. Whatever numbers you put in on this side, leave them there. To simplify, just keep on working on the left side and the right side separately. So 35 is just gonna continue to copy down on this side. 1/2 times 12 is 6. And then times 7. 14 over 2 is 7. This would be 42 minus 7. So if you go down to 35, we did get a true statement. So this was a solution. Or I'm going to put it in a little side note after this, but when you know the highest power of the variable, that's how you know how many solutions there are. And the highest power we had was 1. So there's only one solution, this one. So it would be okay to say x equals 7 is a solution, but we're going to just have a little extra notes to know that there's only one solution in this case. So it's just a little more specific. So this would be, I guess, a fun fact. I would say there are, let's see. Like this. The highest power of the variable can tell you how many solutions an equation has. I don't know if it guarantees that like there are that many solutions, but there are less than or equal to that many solutions. So let's say this power of the variable can tell you how many possible solutions there are. So I'm going to explain it with a few examples, but then let's get back to doing homework problems. So for a while, we're going to work with equations where the variable has a power of 1, and so there's one solution. So your variable is x. The power it has, which we're going to talk about exponents soon, but it has a power of 1 up here. So if it's not written, it's implied to be 1. And so that's your one solution. And we're going to work with equations like this for a little while. In a few weeks, we will get to equations like this. You have x squared minus 7 equal to 5. You look at the highest power of your variable, which this time is 2. And so you could have 2 solutions. Two possible solutions. And I don't think we're going to work with like solving higher degrees or anything. But if you had a variable with a power of 3, you could have 3 solutions. You know, and so on. So let's do like a little bit more. Of x to the 5th minus 2x cubed plus 1 equal to 0. You look at the highest power. So the very first term has the highest power of 5. So you could have 5 solutions. Okay, so let's go back to our homework. So I think we're on to this problem with 4 minus parenthesis 3 minus x close parenthesis equal to 7x plus 3 minus 9x. right, so I need to distribute that negative sign. It goes here and it multiplies over there. Where we have 4 minus 3 is x equal to. Go ahead and put those like terms together. So you have 2 terms with x's in them. This one and this one. 7x minus 9x is negative 2x. Let's also take care of this part here. I see we subtracted 1 from each side. So we're starting to isolate x. So you want to get the numbers together, get the x values together. Okay, so you can get the x values to one side of the equation by adding 2x to both sides. 2x plus 1x is 3x. And we have 2 plus 0x, or 0. Okay, so divide both sides by 3, and then you'll have solved for x. I got 2/3. We should check our answer, but I think I'm going to just put that as a note. And continue on. Okay, so next topic is how to clear fractions. And we'll do a few examples. And then there's another one where we talk about how to clear decimals and more examples. Okay, so if your equation has a bunch of fractions in it, you can get rid of all of those fractions by multiplying both sides by the LCD. So you do have to do scratch work, but at least you don't have to work with any fractions. So let's do this one. Has a variable of m. So m over 4 minus 1/2 equal to 5. So the fractions aren't too bad, but just for practice, we're going on the side and doing some scratch work to get the LCD. That comes from your denominators. So you check out each denominator. I have to wrap it up. Which there's this one, 2 times 2. There's this one, which is just a 2. This denominator is technically a 1. So LCD is the 2 2s. So if you multiply both sides by 4, the fractions will be gone. Okay, that 4 is distributed. 4 times m over 4 is m. 4 times 1 times a negative 1/2 is going to be negative 2. And here, 4 times 5 is 20. You're solving for m. You try to isolate the variable. So add 2 to both sides. And then you have m all by itself. On the other side is 22. That's my solution. Then we have solved for the variable m. And we're out of class time. So I have more notes for homework 2, and then we'll probably be doing this stuff all day next time we meet on Thursday.